Good good morning all, and welcome to our webinar for May with Lindum Packaging. And today's topic is around automated warehousing and the issues faced by automatic warehouses when they have unstable pallets sent to them. Very privileged to have Professor Antonio Galo Ramos from University of Porto with us today. And he'll be helping us answer some questions, no doubt. We'll start in a minute's time. In fact, it's just gone 12 o'clock on my clock here anyway, so let's kick off. So, quick introduction to today's webinar. We're here to talk about automated warehousing, some of the trends in automated warehousing throughout Europe, and the issues caused when unstable pallets enter those warehouses. There's some major problems faced by our clients, and I'm sure companies throughout Europe, and we're here to help solve that. Lindum's a key player in driving down plastic usage in the transit packaging sector throughout UK and Europe, and we work with food and beverage manufacturers to improve sustainability in palletized logistics. As we've said, today we have a guest speaker. Welcome, Antonio.
Hello. Hi.
So, Antonio is a professor at the Mechanical Engineering Department of School of Engineering of Polytechnic of Porto. He's the director of the Master of Engineering and Supply Chain Management, and director of the Centre for Production Logistics Optimization Technologies. He's a senior researcher in the INESC Tech, and main research interests are they lie in developing decision support systems for real world problems, optimization of logistic operations. He stands at the crossroad of industrial engineering, operations research, operations management, logistics, supply chain, and sustainability science. And his research builds mostly on a synthesis of optimization, modeling, and mathematical programming. I think we're in safe hands today. Welcome, and thank you for joining us.
Thank you for inviting me.
So the first question we had today, Antonio, was we're seeing in the UK and throughout Europe, indeed, a very fast growth trend in automated warehousing, automated logistics. And I wondered if you could just tell us a bit about that current trend and why it's happening.
Well, we have been seeing, let's say, the last 15 years, a continuous growth of automations within the warehouse. Of course, e-commerce plays a huge role on this development. Everybody knows Amazon and how the automation in their own warehouses has developed and give them a competitive advantages in their business model. But not only with the growth of e-commerce and the need of higher service levels that, if we can recall a couple of years ago, if you have a two-day delivery, we were very happy. Then we moved to the next day deliveries and same-day delivery. We are talking about half-an-hour deliveries or even less in some cases. So there has been in the logistics sector, mainly driven by e-commerce, this need to increase service levels. But it's not just the e-commerce. We have seen in other sectors, mainly driven by, just-in-time philosophy applied to these different businesses, also a need of high service levels. Of course, if this wasn't a challenge high enough or great enough for the sector, we have been also seeing throughout these years a high decrease in human resources or people to work either in warehouses, either in transportation. So all of this combined have, in a way, let's say, forced the logistics companies to find alternatives for their business. And of course, automation was let's say a clear way, a clear path in order for them to keep increasing their service levels, and came to the shortage, also give an answer to the shortage of personnel to work within their own activities. The development also from big tech companies, we have seen an explosion, let's say, of solutions in this field. And I believe the main one was the AMRs, or autonomous mobile robots within warehouses, that actually drove also this increase in automation. Because when in the past, when we saw and we think about warehousing, we think about different big structures, static structures, high investments for companies. And these mobile robots, in a way, came with solutions which are highly flexible for companies, highly scalable also, and at a lower investment cost. We are not talking about building warehouses that cost 13 million euros or even more. We are talking about smaller, even though they are significant, but smaller investments that bring a high return on those investments, let's say, quite quickly throughout the operations and the development of these processes.
That's good. Very interesting, the trend, and it's definitely something we're seeing in our work, which really leads us on to the next question. And the main topic for today was, what we're seeing is more and more customers are now supplying, so food, beverage manufacturers, and people making fast-moving consumer goods. They're now having the situation where they're supplying into automated warehousing for the first time, not something that perhaps they've done before. And what we're getting is a lot of questions and problems with our clients where they've maybe had something that the warehousing logistics company has put up with for years, a problem, and it's never been a problem, and suddenly they're having to reject hundreds of pallets because they're out of specification, or we've got things like the stretch film coming loose and getting tangled in the machinery and all these type of things. So I wondered if we could just spend a few minutes talking about some of these problems and the kind of issues they cause in the real world automated warehouse.
Yeah, robots in a way tend to not deal very well with let's say, diversity in terms of what are particularly the conditions of pallets. Mm-hmm. We are usually being let's say used in warehouse to see a pallet which is not completely perfect. It's a little bit to the side, the film cannot be as properly placed within the pallet, but of course it's deal with people. It's not a huge problem, we can overcome this, but when we arrive at automation, this variability, it's not well addressed by robots. We need things to be, let's say, within very tight parameters. We have less and less people in the warehouse to deal with this variability, and therefore we need to find processes and tune our logistics processes in a way, let's say, how the automotive business did a couple of years ago within those same processes, in order to diminish that variability in the building, particularly of pallets in the process. If we go back to traditional automated warehousing, the dimension of the pallet in order to be entered in those static racks, it's an issue. If the pallet is off limits in terms of dimension and quality, cannot be fed within the racks. These companies were in a way more or less prepared for an increase within automation. Of course, those companies that come from traditional warehouse operations will struggle a lot in terms of automation and in the quality of these processes. So some of these automated solution, as the AMRs, in a way, they allow the movement and they have a higher tolerance to this variability in the quality of pallets. But when we arrive at different systems, that's not the case, and a huge amount of problems and disruption within the process will of course occur, and companies have to find ways to streamline their processes, reduce the variability in terms of the same processes in order to have a more streamlined logistics operation.
So it's interesting. On some of the key things we're seeing, we deal with palletized goods mainly, and then the warehouses are maybe breaking those down and mixing them and sending them back out. But typically, as the pallet enters the automated warehouse, one of the first things it goes through is some form of laser profile scanner.
Yeah.
And this is where our customers face the first challenge, in that they're having pallets rejected because they're outside of profile. Could you talk a bit more about the importance of that uniformity, both in terms of the size and the shape the robot was expecting, and also the fact that it can't be tilted too much?
No, it has to do with the, particularly in more static warehousing facilities, is that if a pallet is tilted and enters the warehouse, and it has a high degree of probability to fall. And if a pallet falls within an aisle, what happens is that aisle becomes inoperative. So you cannot access other pallets. You basically, all of the products that remain in that aisle are, let's say, unavailable for the operation, which can mean a huge amount of cost. It's not only the damage that can occur in a given pallet that falls and damages the material, but also with all the unavailability of all of those products which are in those aisles that cannot be accessed. Of course, this means a disruption in the process, probably with high costs in terms of operation. So it's something that companies need to of course consider with their partnerships, upstreams and downstreams, the chain, in order to guarantee that what arrives properly. Mm-hmm. But let me add, it's not just on the receiving part, because your companies, these warehouses, are just one dot on the chain, and mm-hmm. They also will build inside. They have to dismantle pallets, build new pallets, dispatch or ship new pallets for the next point on the supply chain, and they have to ensure that also during transport pallets arrive at the destination as they should, without damages to the product. So it's inbound and an outbound problem or challenge for the companies to ensure that in these points we have a guarantee that you have stable, well-dimensioned pallets that can guarantee that the operation is a success.
I think it's very interesting what you point out about the potential downtime of a whole aisle, so that it's not just one product affected, but a whole part of the warehouse. Yeah. You mentioned earlier on about the fact there's less people in these warehouses. Obviously, automation has replaced labor. Yes. But this becomes a double-edged sword, doesn't it? It becomes a double problem, because then when something goes wrong, there's also the lack of labor to then manually solve it.
Yeah, we still have within these warehouses that handle pallets, we still have a lot of personnel. Because one of the main main aspects is that we see a lot of automated movement within the warehouse, conveyors, this AMRs, AGVs. But when it comes to the handling of the product, we still see a lot of manual work. You can say that the manual work is getting more and more focused on the handling, on the building of the pallets, because the automation there is still with a little bit of delay concerning or compared with the movement of the pallets. Either way, it's an extra cost. Even if you have technicians that need to go within those aisles, remove the product, check if there's damages also in the transit elevators. It's a cost. It's a huge cost for companies in a sector that usually doesn't free high margins. So it's not a good thing, and companies, of course, should avoid it.
Yeah, that's very good. I'm hoping you can hear me now because my microphone's just popped up with an error. Can you still hear me?
Yeah,
Yeah,
perfect.
that's good. No, that's good. I think that's really outlines what I was hoping to touch on today. Some of the real life problems the warehouses themselves have, because that helps our clients and our customers to understand the importance of, like you say, a stable, well-dimensioned pallet. The packaging needs to be right, the stretch film needs to be right, the pallet needs to be good, not damaged. All these things contribute to issues in the warehouses. We're going to leave some time at the end of this webinar for questions, which I'm sure will be coming in. But I wondered if you could spend a few minutes now talking about your view of the future of automation in the next 3 to 5 years. I attended a very interesting talk you gave at the UMOS conference about that. So go for it. Tell us what you think is going to happen.
Well, I think in all the studies show that we are going to continue to view or to observe a growth within automation. Technologies are getting more and more mature. We have been seeing a huge, let's say, merger between companies. We are going to have a couple of players because this has been also a movement of the market. We're having huge players that can provide different types of technology, because this is also challenging for warehouses. We want a technical partner that can give us, let's say, all the services. The robots must be compatible with our warehouse management systems. We have to have everything integrated. But we will be observing this growth the next years, and we will, I believe, to see also a growth in this, let's say, less automated parts of the warehouse operations that we are seeing today, which is the handling. There has been a huge investment by these companies, let's say, to finish the whole product by including a better handling of the products in order to comply with all these requirements of just-in-time philosophies, e-commerce, packaging, etc. That are currently, let's say, the main challenges that we face within the warehouse. Of course, other challenges will also be present, that probably automation comes at help. We are also going to have to observe a huge pressure from the environmental part in terms of usage of transport. And this means that the cargo within trucks, within containers, must, particularly in trucks, the volume usage and capacity of the trucks must be better used, which means that we will probably have higher pallets, heavier pallets, compared to the ones that we have today, which will provide new challenges, particularly for the pallet building operations, in terms of stability, integrity of these pallets in the coming years. But this is a non-stopping path that we are going through, that will only grow as time goes by. In the next, I believe, 5 to 10 years, this is the path within warehouse. It's every kind of automation, and new solutions are appearing every day. So I don't think that it will stop as soon as.
It's definitely something that's growing and progressing and changing the whole time, isn't it?
Yeah.
One interesting conflict we see is from an automation point of view, the warehouses are looking for consistency, and if everything could be the same shape and size, that'd be the perfect world. But then you have the brand owners and the retailers, for something to stand out on the shelf and sell more, they want something that's different. How do we balance that one?
Oh, that's an old one. No, that's an old challenge. We used to say that we in the logistics, guys in operations want rectangular shapes. The guys in marketing and sales, they want round shapes for capturing the customer. I believe that there will be a huge pressure from this environmental part of the business, directly in terms of costs. In some countries, we are already seeing that in terms of plastic related taxes. So when we go, companies, when they will look at their whole supply chain, how things are packed, shipped, transported, which currently they actually don't look at it they look at, but within some giving it some gaps. I believe we are going to see also there some changes in the way that things are packed, transported throughout the supply chain. There's a huge amount of work there that needs to be addressed, not only within the materials, but also within the dimensions. And some companies already address that by realizing that a product that is developed and packed for the brick and mortars retail, it's not the same as a product within the e-commerce channel.
Yeah.
So the way that the customer looks at the product, receives the product, uses the product, sometimes is also different, and they are already building different packages for the different channels in a way. But that's surely one of the ongoing challenges, which is, as I said, not new, that we are going to need to adapt and adjust throughout our operations.
Yeah, that's good. Okay, so we've had some questions start to come in. I've got one here from Huey Patrick, and what he's asking is, he said, I see these issues, some of these issues now automated warehouses, incoming tilted pallets on absolute bane. How do you go about starting, suggest I start trying to fix this? Well, I think we've got some answers, and you've probably got some as well, but one of the things we would always suggest is, if you have pallets moving in transport and you have that as a problem, the first thing to understand is what's going wrong. So you need to get back to data. And as you know, there's plenty of things that can be done around testing. Deacceleration testing using the UMOS method is a very good place to start. And it'll give you an idea of why your pallets may be moving in transport when you subject it to the kind of forces that you'd see. And then beyond that, you need to start gathering data. Is it always happening the same way every time, or are you seeing some random variations, and it's then harder to solve? But what would you say? How would you suggest you go about this?
Well, I think you're absolutely correct, Rick, because it's not just you need to know what's happening in the process. From the time you build the pallet to the time you deliver it, you need to know where identify where the problem is. Was it the pallet was poorly built? Was it the way that the film was wrapped around the pallet? Was it properly done? Does it have the proper quality for that particular packaging? How the transport is done? Was the cargo properly placed within the truck? How the driver actually drove between point A and point B? As we know, there's a huge amount of difference within the driver's behavior as a consequence also to how the pallet behaves during transportation. So you need to also to map all your process and to identify if it's a once in a lifetime one problem that you have on a pallet, or if it is a problem within your process, and address it in the proper way, either by testing, requesting for consultancy for these operations, in order to diminish, of course, and to reduce the risk to the maximum that we can.
Yeah, I think that's good. So another question that's come in this morning was about artificial intelligence. I thought this might come in. So someone's asking, how is AI going to affect warehousing?
That's a tough one. Now, within this, I believe AI has a role, of course. I think it's very, when we move to automation, we are looking at it as removing the human from the the decisions, let's say, in a given way. We deal within the warehouse very complex processes. When we think of an order picker, for example, that during the picking process, he starts building the pallet. He, at the same time, he observes the geometry of the product, the weight, the condition it is, where he's going to place that given box. Even though for us it's natural, all these decisions, all these processes, for machines it isn't. A machine needs to doesn't know what gravity is. We need to build the software in a way that gravity is reflected on the software when it decides where to pack, how to pack, etc. Artificial intelligence, I think, will play a big role in identifying all of these features, characteristics within the process, which are very hard to capture throughout traditional decision support systems. I think there we have can leverage all the, let's say, machine learning, not artificial intelligence. It's a little broader. We'll leverage by identifying where the problem of the product is, looking at a given pallet and try to identify the reason for the tilting, the collapsing of the pallet. It will, of course, give us a huge help within the warehouse activities, in particular within this pallet stability issues. I think so. We are internally within our research lab using these tools to help us build better pallets, more stable, more suitable for transportation. So we are already using it, and I think in the next years we will see very good developments in this area.
That's good. I think we've got one last question, and then we're about done on our time. So Sean Knox is asking. He's saying, what about corrugated cases, so that's cardboard boxes,
Mhm.
and the lateral forces they'll be expected to withstand. Is there a methodology available to test this beforehand?
I I did not quite understood
Yeah,
what.
I think the question is around the fact that when you're handling this is probably for pick and place applications particularly. The corrugated cartons are being handled in a different way to how they would be if a human was picking it up and moving it.
Yep.
And so he's asking, is there a way of testing beforehand before you just put it in and see if it works?
Oh yeah, there are ways for testing. We use simulation software for that, and that's one of the ways that we are using machine learning. Is that when we are, let's say, building the pattern for loading, for example, in a picking operation, you can simulate what happens if you have, for example, the corrugated cardboard box model within specific mechanics, engineering, warehouse software. Sorry, and what we are, or one of the approaches is using the outcomes of these softwares in a learning approach in order to combine them with the decision building software for the pallets. But it's still, let's say, in its infancy, these types of approaches, in order to guarantee that we will have a stable pallet, that we do not have any kind of crushability throughout the building of the pallet. But it's feasible. Let's say it's technology that already exists. It just requires for integration, let's say, of these different technologies.
I think that's good. What to me it points up is the importance of understanding your supply chain before you start designing the packaging.
Yeah.
And from a packaging point of view, there's a very simple strength test we can do on a box. It's called BCT, your box crush test. And so if you're working with your logistics provider, if you know it's going through a pick and place operations, you need to talk to them and understand at any one point what's the maximum force this box needs to withstand. Is it likely to have other packages stacked on top that are not the same as it is, i.e. a mixed pallet? And then we can very easily calculate how strong the box needs to be to withstand that force. And then you can be quite assured that when you put your products into the supply chain, they're not going to get damaged. Good. Well, I
Yeah.
think that wraps us up for today. We're slightly over time, but it's been very interesting for me.
Hmm.
Appreciate your time and thank you for joining us.